Recursion in Python, as in many programming languages, is a method of solving problems where a function calls itself as a subroutine. This allows the function to be repeated several times as it can call itself during its execution. Here's a simple explanation and an example. Basic concept. In recursion, a problem is divided into smaller subproblems of the same type, and the function solves the smaller subproblems. The process involves base case, the condition under which the recursive function stops calling itself, preventing an infinite loop. Recursive case, the part of the function where the function calls itself with a smaller or simpler input. Example: factorial calculation. A classic example of recursion is calculating the factorial of a number. The factorial of a non-negative integer, n, is the product of all positive integers less than or equal to n. It is denoted as n. The factorial can be defined recursively as 0 等于 1. 0 is not equal to 1 base case 等于乘 minus 1. N equals n times n minus 1. 4. 0. N greater than 0, recursive case. Here is how you can implement this in Python. Python-def factorial n hashtag base case. If n equals 0, return 1. Hashtag recursive case. Else, return n asterisk factorial n1. How it works. Initial call, factorial 5 is called. Recursive calls. Factorial 5 calls factorial 4. Factorial 4 calls factorial 3. Factorial 3 calls factorial 2. Factorial 2 calls factorial 1. Factorial 1 calls factorial 0. Base case, factorial 0 returns 1. Unwinding. Factorial 1 returns 1 times 1 is equal to 1. Factorial 2 returns 2 times 1 is equal to 2. Factorial 3 returns 3 times 2 is equal to 6. Factorial 4 returns 4 times 6 is equal to 24. Factorial 5 returns 5 times 24 is equal to 120. So, factorial 5 ultimately returns 120. Key points. Stack depth. Each recursive call adds a new layer to the call stack. Too many recursive calls can lead to a stack overflow. Efficiency. Recursion can be elegant and straightforward, but it may not always be the most efficient approach due to the overhead of multiple function calls. Iterative solutions can sometimes be more efficient. Example: Fibonacci sequence. Another example is the Fibonacci sequence, where each number is the sum of the two preceding ones. The sequence starts with 0 and 1. Here's a recursive implementation in Python. Python-def Fibonacci n hashtag base cases. If n equals 0, return 0. If n equals 1, return 1. Hashtag recursive case. Else, return Fibonacci and 1 plus Fibonacci and 2. While this code is straightforward, it's not efficient for large and due to repeated calculations. This can be improved using techniques like memoization or an iterative approach. Summary. Recursion is a powerful tool for solving problems that can be broken down into simpler, similar subproblems. Understanding the base case and recursive case is crucial for writing effective recursive functions. However, it's important to consider the potential performance implications and choose the most appropriate solution for your problem.